design, we normally find the inlet and the outlet for one fluid at the very end of the heat exchanger, known as the header. Then we have another inlet and outlet for fluid 2 on the main body, known as the shell. Inside the unit, we have the tubes. These bend and loop around to start and finish at the tube plate, which sits between the shell and the header. The tubes will usually also pass through some baffles, which are sheets of metal. We will see how these work in just a moment. The header, as well as the tubes, can be removed for cleaning, repairs and maintenance. Inside the header is a sheet of metal known as the divider, or the partition. This separates the tube ends, enabling the fluid to flow into and then out of the heat exchanger tubes. Fluid 1 will flow through the header, into and around the tubes, then back to the header. Fluid 2 will enter the shell and surround the outside of the tubes. The baffles will partially block the flow, which will force the fluid to turn multiple times. This creates a turbulent flow and ensures that fluid 2 mixes with itself, which ensures maximum heat transfer. For example, we might find this in a pharmaceutical factory with a boiler providing steam into the shell, which surrounds the tubes. A chemical product is then pumped through the tubes, and this absorbs the heat of the steam through the tube wall. So this product is going to exit the heat exchanger much warmer. Meanwhile, the steam will start to condense into a liquid and flow back to the boiler to pick up more heat and repeat the cycle. Additionally, these are used in refrigeration applications, like this industrial chiller. We have the water flowing through the tubes and the hot refrigerant in the shell. The water will absorb the heat of the refrigerant so that it can transport this to the cooling tower